Hello, this is Dr. Oz. In this video, I would like to show you how to forecast using naive forecast. So here I have 12 weeks data. I enter that, and I have thousands of gallons of sales historical data, and I will make my forecast here. Maybe I will color code these values as green, and I will calculate my errors here in this area, and absolute error, squared error, percent error, and absolute percent error. So these are the calculations that I will make here. Okay, so let's start with naive forecast. So since all I have is week 1 data, and if I'm trying to make a forecast at the end of the first week, all I do is forecast based on previous period. All right, now I can drag this one down and I can make forecast for the next 11 weeks. I could do it next week as well, week 13. However, that won't help me because I don't have data yet. So I cannot calculate whether, I cannot validate my model whether it's a good model or not. Again, it's about forecast accuracy and validating our model. So how can I calculate my error? Again, I like to do my forecast minus reality. So I'm underestimating reality by -4. And I can drag it down. All right, so now I can calculate absolute error by just taking the ABS function of these values, which will make our negative values positive. Drag it down. Now I would like to do squared error. Take the error, take the square of the error, which will eliminate the, again, positive and negative numbers will cancel each other out problem, and drag it down. And I can calculate my percent error, basically my error, -4 divided by sales, real sales. And you can see that I'm underestimating the reality by 19%. So I can drag it down. And I can calculate the absolute value of this ABS function again, which will convert negative numbers into positive numbers. Beautiful. Now I can calculate my totals. We're using sum function in Excel. Maybe I will do this for just errors. So my total error in terms of number of thousands of gallons is I'm underestimating reality by 5,000 gallons. So that means that my model has a bias problem of 5,000 units total. And if I divide this by 12, I can calculate the average bias, which is 400 gallons something, 400 plus. All right, so this is good. So I can take the again sum of, I can drag it right to calculate all the sums here. For the percentages, really this doesn't make any sense, but you can see the square error is 179 total and absolute error is 41. This shows us the magnitude of the error. So on total I have 41. To see average error, I can take the average of this column, which will give me 3.73. So my model is wrong on average by 3.73 units. In this case, units is thousands of gallons. So I'm off by 3,700, around 3,700 gallons. Okay, my model is off by 3,700 units. I can do the same thing for squared error. Again, I want this value to be as low as possible. However, it's hard to grasp this because square of the gallon doesn't really mean anything. But you can see that this number is 16.27. And this is my personal favorite, calculating the mean absolute percent error, which is MAPE. Just basically take the average of the absolute value of the percent errors. And on average, my model is off by 19.24%. So in next videos, I will use different forecasting tools and compare their performance based on mean absolute percent error, and will decide which forecasting model is the best for my data, and I will make forecasts for the future based on those that model that gives me the best results. Until next video, enjoy business analytics.